Let's discuss about average speed and average velocity. So we are going to use back the same example of this person running from the origin towards x equals to 4, make a U-turn, then run towards x equals to -7. And this whole journey here takes up a duration of 5 seconds. So if we analyze the average speed from t0 to t3, we can calculate it by getting the total distance traveled, which is 4 plus 4 plus 7. We add on without caring about the direction here, just add on the length of the path travel. Then we divide by the duration, and we say this duration is 5. So 15 divided by 5 is 3 meters per second. If you're not sure about what am I saying, you can watch back the video on average speed. Okay, and also we will be discussing t0 to t3, the average velocity as well. For average velocity, we take displacement, which is s vector s, divided by the time duration. Again, when we talk about displacement, it's always the initial and final that we care about. We don't care about how it happens in between. So our initial is t0, so our initial position will be at x0, and our final moment is t3, so our final position will be at x3 over here. So if we take x3 minus x0, you will get -7, then you divide by the time 5 seconds, you get -1.4. But since it's negative, when we change it to vector, we keep the magnitude as positive because the magnitude of a vector must be positive. But the negative sign that was previously used to determine direction, we translate it into direction inwards instead. So you write towards the negative x direction. Okay, so why do I put this average speed and average velocity side by side? Because I'm trying to tell you that average speed and average velocity are totally two different things. As you can see here, the answer is not the same. One only has magnitude, one has magnitude and direction. One is 3 meters per second, the other one is 1.4 meters per second. Well, they are two different things, and if we think about it in greater depth, we will know that this 3 meters per second here is representing the speed that you should be traveling in order to cover this much total distance in 5 seconds. If I want to cover 15 meters in 5 seconds, I have to travel 3 meters for every second that has passed. That's the idea of average speed. But for average velocity, it does not depend on the path travel. As you have seen just now, I totally don't care about the U-turn that it's made by this person over here when it's running. I just care about initially it's at the origin, at the end it's at x equals to -7. I don't care about the path in between. And as you can see, the answer 1.4 meters per second towards the negative x direction. What is it trying to represent? It is trying to represent the most direct way to go from initial position to the final position using the amount of time specified. In this case, how can I travel from the initial position, the origin, to the final position, x equals to -7, in 5 seconds? I can do it by traveling to the negative x direction. For every second that has passed, I travel 1.4 meters. Then by the end of the 5th second, I'll end up at the final position, as being mentioned from t0 to t3 that we say over here. Okay, so this average speed and average velocity here, they are representing two different things. One depends on the path, one does not depend on the path, and as you can see, the magnitude are different. So we can make a conclusion that actually these two physical quantities are not exactly related. Okay, so this is average speed and average velocity. Now let's look at instantaneous speed and instantaneous velocity. We're going to compare between instantaneous speed and instantaneous velocity. Again, the same example, this U-turn example, but I'm going to specify this time t. I'm going to investigate just this moment t over here. Okay, so again, if you remember from the previous video on instantaneous speed or instantaneous velocity, you know that what we investigate is within a very short duration dt, what is the change in the position, or what is the change, or what is the distance traveled within that really short window of time. That is what we investigate when we talk about instantaneous speed or instantaneous velocity. Okay, so if we talk about instantaneous speed, what we do is we take total distance traveled within that short window of time, divide by that short window of time itself. Distance divided by time, limit the duration to 0. So a very, very short window. So this is instantaneous speed, speed scalar quantity, no arrow on top. But if we talk about instantaneous velocity, it's a vector quantity, so there's an arrow on top. So this will be displacement divided by time duration. Again, previously in speed, it was distance traveled divided by duration, but now it is displacement divided by time duration. In this case, the displacement here, because we limit the duration to be approaching 0, we are actually only interested in the displacement that happens within that very, very short window of time. In this case, it is actually indicated here. Within this really, really short time dt, I only managed to change my position by this much, which is dx over here. And in the video, I actually explained that this dx here is in the same direction as the direction of motion. So if we change the limit, we can change the delta to become d, an infinitesimally small change. So this is the equation for instantaneous velocity. Okay, so we are clear now with instantaneous speed and instantaneous velocity. Now let's try to make some comparison between them. Okay, under the limit delta t is approaching 0, short moment of time, we can actually see that this total distance traveled here is actually the same as the displacement that happens actually. Okay, if you think about the situation, if I want to measure the distance traveled within that short amount of time, I'll have to measure the distance between this gray dot and this black dot over here, right? Because within that short moment of time, it only moved by this much. So you measure how much distance that is traveled, but within that short moment of time. But if you think about it, right, the displacement is a change of position within that short amount of time. Well, within a short amount of time, you cannot make complicated curve move or turn a circle to reach the final position. You have to go straight from the initial position to the final position. So if you are measuring the displacement, right, the magnitude of the displacement that you are measuring is actually itself the total distance traveled. Okay, this displacement here is a vector, right? So there's magnitude and direction. The magnitude here is actually just the distance traveled. Because within a short amount of time, you cannot make complicated patterns between the initial and final position. Okay, so if we know that the magnitude of displacement is equal to the total distance traveled, we will know that if we substitute the same value for magnitude up here, the same value for duration down here, what will happen is you get the same answer for instantaneous speed and instantaneous velocity. Just that instantaneous velocity also need to include direction. Okay, the value, the magnitude that you get for speed and instantaneous velocity will be the same because the total distance traveled will be the same as the magnitude of the displacement. So the magnitude of instantaneous speed and instantaneous velocity will be the same, just that instantaneous velocity you also have to include direction. Okay, so with that said, we can say that instantaneous speed is actually equals to the magnitude of instantaneous velocity. In other words, if today I tell you this object here is moving at the velocity of 5 meters per second to the left, then straight away you can say the speed is 5 meters per second because the magnitude of the instantaneous velocity is instantaneous speed. So speed and velocity are, if you're talking about instantaneous speed and instantaneous velocity, they are the same thing, except that instantaneous velocity also includes direction. Okay, that's how you relate between instantaneous speed and instantaneous velocity.